Hey guys, welcome to lesson 7.1, where we're going to talk about simplifying radicals. Another word for square root is radical. So when I say the word radical, that goes beyond just square root. Like we could be talking about cube roots or fifth roots or 10th roots. It doesn't matter. This is more like a general term for any kind of roots that we're going to talk about. Okay, so find the radicals. So what we're going to do is just kind of see like what you know about square roots. So do you know the square root of 25? So the square root of 25 is 5. This one's a little bit more difficult. Square root of 144, that is going to be 12. The square root of 81 is 9. So we've kind of already talked about these when we were talking about difference of squares, but let's kind of talk about why this works. So what I want you to do is think about all the squares of these. So like 1 squared is 1, 2 squared is 4. I'm going to keep continuing through these. Okay, and so why this is important are these are all of these numbers here and all of these numbers here, they're called perfect squares. And why they're called perfect squares is because we can take the square root of them. So if I wanted to take the square root of 9, that's going to give me 3. If I wanted to take the square root of 36, that's going to give me 6. If I wanted to come over here and take the square root of 196, that's going to give me 14. So all of these numbers you can square root and it ends up a nice number. So let's go back up here. Like the square root of 25, I'm going to look right here. Square root of 25 is 5. So that's why those all work. They're called perfect squares. And we're going to get more into that here in just a second. Something else I want to talk about is this notation. And we've talked about this before, but I want to bring it up again. So anytime you have this number on top, that's your exponent. And anytime you have this number on bottom, that's your root. And remember, 2, we don't put a 2 there, but it means square root. So whenever you see the exponent 1/2. So anything to the 1/2 power, it's just talking about a square root. So let's go down here. So when I say y to the 1/2 power, in my head, I'm just going to think, okay, what's a square root of y? Same thing with this. 9 to the 1/2 power, what is the square root of 9? And I can actually take the square root of 9, and that is 3. So what if, look at this 8, this 8 is not on the list. It jumps from 4 to 9. And so we don't have an 8 as a perfect square. So how do we handle this? We are going to try to find factors that are perfect squares. So think about factors of 8 that are going to make this list. So 1 isn't really going to be helpful to us ever because 1 is a factor of everything. But let's go down this list like 4 and 9 and 16. So which one of those is a factor of 8? And you guys can see that 4 is a factor of 8. So I'm going to put that factor first. And then whatever's left over. So 4 times what is 8? And that's going to give me a 2. Okay, so what happens is I can split this up so that it looks like that. And now I can take the square root of 4, which is going to be 2, and then I'm just going to bring down the square root of 2. Okay, let's do this one. This one's a little bit tricky because 4 goes into it, but something bigger can go into it. So I'm looking for the biggest exponent that would go into 32, and that's going to be 16. So when you're going through these, especially with the bigger numbers, I would try to go a little bit past the first one that you see, just to make sure that there's not a bigger one. So you should see that 16 times 2 is a factor of 32, or are factors of 32. Okay, and so I'm going to split this up again. So square root of 16 and square root of 2. And sure enough, I can take the square root of 16. Let's look back up here. So the square root of 16 is 4. So I'm going to say 4 square root of 2 for my answer. Okay, let's try 24. So let's see. And what's nice about 24, like I know it can't be that one. Really 16, I know doesn't go into 24. Does 9 go into 24? Nope. 4 goes into 24. So 4 goes into 24 6 times. And so I'm going to split this up. Square root of 4, square root of 6. The square root of 4 is 2. And I have 2 square root of 6 for my answer. Okay, let's keep going. I want you to try these next 3 here. Okay, so let's see. This one, I have a 4 square root of 3. And so I'm going to take the square root of 4 times the square root of 3, which is 2 square root of 3. This next one, 50, the square root of 50. I can break this up into 25 and 2. So I have the square root of 25 and the square root of 2. Well, the square root of 25 is 5. So my answer is going to be 5 square root of 2. Okay, let's look at this one. So this one, if I go back, let's see and check it. Let's see, 4 doesn't go into 13, 9 doesn't go into 13. So I don't have anything that I can simplify, and that's okay. That's as far as it can go. So it can't be simplified any further, and we just leave it alone. Okay, let's go down here. We talked about how this is the same thing as the square root of 28. This is the same thing as the square root of 18. This is the same thing as the square root of 44, and this is the same thing as the square root of 20. Oops. So what I want you to do is push pause and see if you can simplify these just like we've done before. Okay, so this is, let's see, 4 times 7 is 28. And so I'm going to take the square root of 4, which is 2, and then I have the square root of 7 left over. This one, I know that 9 times 2 is 18. And again, guys, we're looking for the perfect square to go first. And the square root of 9 is 3. And then we have 3 square root of 2. Okay, over here, I am going to take, let's see, a 4 out because 4 times 11 is 44. And I'm going to take the square root of 4, which is 2, and the square root of 11 I can't take, so it's going to be like that. Let's do one more, and then I want to say something real quick. Okay, so the square root of 20 is 4. I'm sorry, the square root of 20 is 4 times 5. And then I'm going to take the square root of 4, which is 2. And then I can't take the square root of 5. So I want to say something. I get this every year. I'll have students do something like this. So this is right. So 20, 2 factors of 20 are 10 and 2, but I can't take the square root of either of them. So that's why it's important when you're looking at those factors, you're just looking at these over here. I do not care about any other factor except the ones that are the perfect squares. That's it. Now we're just going to talk about just a couple of weird cases, and they're actually pretty easy. So think about this. If I take the square root of something squared, those are going to cancel each other out. Because think about this. This is like 3 to the second power, and my root is 2, which is 3 to the first, which is just 3. So anytime you have a squared under a square root, they just cancel out, and it's just that number. This is going to be X, this is going to be Y. So be on the lookout for those. Those are kind of nice. Same thing here. So if I raise a power to a power, those cancel out and give me 3 to the first. And basically, this is just another way of rewriting that. So if you see something like this, it's just the number as well. And that is it.